All right, Circus. So let's see. So Circus is a tool we've been building at Mozilla, and it's a process and socket manager. On this slide, I'm showing what is a typical deployment in the Python community when you deploy a Python application. If you deploy differently, please let me know, but I think this is pretty standard. So you have your Python application, it could be Django or Pyramid or whatever, and you use a WSGI server. It can be JUnicorn, or you have many other servers like this that are basically maintaining some Python processes. And the JUnicorn server serves queries at a given port. And then you have Nginx in front of it that reverse proxies calls to JUnicorn. It could be also Apache or whatever. There are like a couple of other ones that are used, but basically that's a very specific, very standard way of deploying Python-based stacks. And what I've seen out there is that most people use virtualenv or something similar and create their Python stack in the user space. And then they have, at the root level of their server, the Nginx deployment, so they can serve their Python application. So raise your hand if you do things differently. Okay, so everyone works like this, yeah? Okay, cool. And then, beside your Python application, when you start to have more complicated stuff, you usually start to have other processes that are running for your app. You have, I don't know, Elasticsearch server, a SupervisorD daemon, a Sentry server, maybe if you have a single box and everything is in this box. So basically the idea is that a web application built with Python is not a single Django or Pyramid process that runs. You have many other stuff that runs, what I would call co-servers that you need to run and maintain. And then we have Supervision Tools. Okay, so when you have all these processes running on your box, you need to make sure that if a process goes down, there is something that will put it back up. And to do this, you use what's called a supervision tool. So who knows about supervision tools? Okay, so when we wanted to start to use supervision tool, we'll look at what we had around. And so basically in the Python community, most people use SupervisorD, which is built and maintained by Chris McDonough, I think, which is one of the Pyramid guy. It's been around for a while. It's written in Python. It's pretty mature, and you can interact with it using XML RPC. There is a good community since it's used a lot, and but when we started to use it, we found that it was a little bit hard to extend, and the web user interface that's provided in the project is very minimal. It's just a web page that displays processes. It's not a real-time web page. You don't have a lot of fancy feature. That's the last time I checked. Maybe now these days it's way better. I don't know, but when we checked, it was not really good. And you can't have features like real-time standard output. What if I want to follow what's going on in one of the Django or Pyramid process and just tell all the real-time standard output or standard errors? You cannot do this. It has some tailing feature, but not what we wanted. And then we looked at other tools. So this is a list of tools we found. There is one called Blue Pill. Bluepill is written in Ruby, I think, and it has a domain-specific language. So basically, if you want to maintain some processes, you have to write a specific file with a list of process, and it's a little bit tedious. It's yet another DSL you have to learn and interact with. But it has a really cool feature. It has the flapping feature. So what is flapping? Basically, when you launch a process that's borked and your supervisor run your process, is going to go up and then die immediately. And if your supervisor is not handling things correctly, it's going to try to start it again and again and again and again. And this effect is called the flapping, and what happens is that you have a server that doesn't work and eat 100% of the CPU just because it's trying to start the dying process all over the time. So the flapping feature is pretty important to have. Then there is Upstart. So Upstart is, I think, the default supervisor in Ubuntu, I think, these days. Maybe it was replaced by systemd, I'm not sure. Do we have a Ubuntu specialist? Okay, so the slide is still good. Okay. So, but the thing is, Upstart is at the system level. So you have to be root, and you have to be able to add your processes at the root level when you use Upstart, which is fine if you root on your server. But as I said earlier, most of the time people that are writing Python web application deploy them on their user space, and it's not easy to have your own Upstart in your user space unless you do a chroot or something like this. Daemon Tools. So Daemon Tools is a real low-level tool like Upstart. That's what we used at Mozilla before we switched to Circus. Daemon Tools is basically a very simple binary that will look for your processes and make sure they're staying up, but it doesn't have any features. Like you cannot really interact with it. You can send some signals, but that's about it. And there is also God, Monit, RUnit, etc., etc. But we thought we looked enough around to make our choices. So, when you deploy a Python stack with a supervisor, what you usually do is you have for example, on Ubuntu, you have the Upstart service, and you ask the Upstart service to watch Nginx. And then SupervisorD is the one in your user space that's going to be responsible to look for JUnicorn, SupervisorD, Sentry, Elasticsearch, and it will make sure that all those processes will still run. It's a little bit strange, I must confess, to have two supervision tools for a single stack, but that's usually how people do. Because I don't think of deployment where Nginx is included in the Python stack, in the user space. So, SupervisorD is basically what we wanted to use when we started to look at this, but it has some missing feature. We wanted to be able to have real-time standard output and standard error on all our processes. We wanted to be able to have real-time statistics. For example, I want to plug some script in a stream of statistics and know exactly how much CPU and memory every process in my stack is using. So, well, you can do it using the XML RPC API in SupervisorD, but it's a TCP call. So basically, it's hard to make it real time, and you have to poll all the time if you want to do it properly, which is a little bit annoying. Remote access. We want to be able to run a console on another box really easily, and we want to be able to manage several boxes without having to run a CTL script in each one of the boxes. So basically, if I have 10 Circus deployed out there, I want to be able to interact with them from the same console. Clustering. That's a feature we wanted. We wanted to be able to transparently manage several boxes, and on each one of those boxes, several processes. So from the same console, I want to be able to say, hey, I'm going to add this process in this box. I want to see what's going on in that box, etc., etc. And last but not least, we wanted to be able to let our ops team write event-based plugin. So, for example, if they want to plug Circus with some other tools and they want to have some information about what's going on, it's really easy if you have an event-based plugin where you can just write a little bit of Python to say, hey, every time a process on that box, every time a process eats more than, I don't know, 10% of the memory, please send an email to that guy, or please do this, etc., etc. So yeah, we had enough excuses to start our own project. So that's how Circus was started. All right, so the technical choices. So for building Circus, we used PSUtil for managing our processes. We use ZeroMQ for all the message passing. We use Socket.io and Bottle and Gevent for the web console, but that might change in the future. I'll explain why. And everything else is just pure Python. So PSUtil, who knows this project? All right, so this is a really, really cool library. We like it a lot because it has clean, simple APIs to interact with processes. That's a small example here. And it's really fast, because when you start to manage a lot of processes, if you don't have a library that does the proper thing, it eats a lot of CPU. And when we started to use PSUtil, it turns out it was really slow when we had more than 100 processes. And we found some bugs in the way PSUtil was working with the proc files on Linux that made it really slow, but it got fixed eventually. And if you use the version after 0.6.1, it's super fast. So if you build a Python program that interacts with process, I highly recommend PSUtil. All right, so ZeroMQ, who knows about ZeroMQ? Yeah, so it's very, very popular this day because it has a lot of interesting features. I'm not going to talk extensively about ZeroMQ because it would take a full talk. So that's my only slide about ZeroMQ. So ZeroMQ, for those who don't know about this, is an async library you can use to do some message passing. It's basically it acts like a smart socket. Instead of having to deal with all the low-level mechanics you would need to interact with someone in a socket, ZeroMQ does everything for you. It provides patterns to do some request replies, some pop sub, and some push pull. So for example, if I create a ZeroMQ socket to publish some events, it's dead easy to create this. It takes a few lines of Python, and then anyone can register to this socket, and like in Redis, you can just listen to some specific events by filtering out some stuff. So that's the pub sub. And the push-pull is just a tube where you push data in it, and on the other side, someone can pull it. And the request reply is just you send queries and you get back some responses. This ZeroMQ, one of the IPython developer created the PyZeroMQ library, and it's actually used by IPython. It's I think the only ZeroMQ binding in Python, and it's really nice. And it provides, beside all the APIs to interact with the ZeroMQ socket, it provides IO event loop from Tornado. So basically, what they did, they took the Tornado event loop, they stripped it to a very simple version of it, and they added it in PyZeroMQ. So building a PyZeroMQ application means that you just run a Tornado loop, and you just plug all your ZeroMQ socket and build some code that reacts from the loop. And since it's used by IPython, it's pretty robust, it's pretty fast. Oh, one more thing about ZeroMQ. So those sockets can be using several different transport. For example, you can use plain TCP just to say, hey, I'm going to open a ZeroMQ socket on the port 8080 or whatever. But you can also use other transport. For example, you can simply run IPC sockets, inter-process socket, when all your different processes are on the same box. So instead of opening a TCP socket, it's going to use a file and interact with the processes will be able to interact in the file. And ITC is inter-thread communication, so you can even have threads in the same process interact with a ZeroMQ socket. What that means is that you can build a ZeroMQ application and just by configuration decide if you are going to use TCP or IPC or whatever. And for Circus, what it means is that if your Circus is on a single box, you don't even have to open a TCP socket. You can just open IPC files, and everything will stay in the same box. All right, so this is the Circus architecture. So basically, what's Circus? Circus is a daemon called CircusD. This daemon is the one that forks all the processes and manages them. And this daemon opens two ZeroMQ sockets. One is a pub subsocket where all the events about the processes are sent, published. Basically, every time a process is started or dies or do something, it's published here. And the rec-rep socket here is basically a socket you can use to interact with CircusD. So for example, you can control, add a new process, remove a process, and just drive CircusD using this socket. And since it's ZeroMQ, it means that you can even write another program in another language and interact with CircusD. There is a guy out there that created a Ruby program that uses CircusD without any issue because you will find ZeroMQ bindings in every language. And here we have a separate process called CircusD stats, which basically is responsible to publish statistics about the memory and CPU usage of your processes. It's a separate one because in some project we don't care about that, so we don't run it because it's very, very CPU consuming. If you have a lot of processes, the fact that you have a process that will regularly look at what's going on is going to take a lot of CPU. And CircusD stat has its own pub sub socket, ZeroMQ socket, where it publishes at regular times what's going on in the Circus stack. And if it crashes, CircusD is still there, so it's more robust to have a separation like this. And CircusD stat also consume events from the CircusD pub socket to know what's going on. For example, when a process crashes, CircusD stat will know about it and make sure it maintains its own list of processes. And then, with all this system, we started to provide some tools. So one of them is CircusCTL, which is basically a command line you can use to interact with the system. CircusCTL is just calling the CircusD process using this socket, and that's where you go when you want to add a new process or know what's going on in your stack. CircusHTTPD is the web dashboard, and the web dashboard uses the same sockets to do the same kind of features, adding or removing processes and stuff like this. And it also uses the CircusD stats sockets to get a real-time stream of all the statistics of your processes. And last, well, this one is just for fun, I guess. It's CircusTop. We built a top-like tool where you can just display all the processes you have in Circus in your console. So is that clear? Do you have any question about all of this? Yeah. Oh, so basically this one is a loop that wakes up like every second or something, and for all the PIDs you have will collect stats and publish them, and by subscribing to the events here, it's able to keep up with the list of PIDs that are running in the system. Because this one doesn't know what are the processes that are managed by CircusD. Okay, well, we can come back later to this after if you want. Okay, so recap. So we have CircusD is the daemon that watches all the processes. We have CircusCTL, which is the command line tool you can use to interact with your system. CircusTop, which displays the process activity. Circus HTTPD is the web console. And also we have the plugin command that you can use to run a plugin that will interact with the system. That's the one here. Okay, so if you want to run a Circus stack, you need to write a ini file where you define what processes you want to run. In this example, I have one Django application that's running through JUnicorn. I'm saying it's a singleton, so I'm going to run just a single process. And I also have workers, Redis workers. It's using a library called retool. And here I'm saying, hey, I want to run 5 of them. And then I have 2 options here. I say I'm going to activate the web console, and I'm going to activate the stats. And that's it. And then you launch it using CircusD. It reads the configuration and runs the system. That's the CircusCTL interactive shell. So basically, you can run CircusCTL. Is gonna hook on CircusD and give you all those commands so you can interact with the system. So we have stuff like add to add a process, dec to remove a process, list to list all the watcher, all the programs you have running, and reload, quit, set, all the typical stuff you need to interact with the system. And if you use the interactive shell, you can type help and the name of the command, and you'll get information about how to use it. But it's pretty simple. Like signal, you can send a signal to any of your processes that are managed by Circus, stuff like that. So here I have 2 examples. Num process retools worker will let me know how many processes are running in this one, and inc retool worker will add a new process and tell me that it has 6 processes now. I never type in real time when I do talks because it never works. So that's that. CircusTop. So you run CircusTop and you have a screen like this that's exactly like Top, but only for the processes that are managed by Circus. And they're organized into program. And for each program, you have the PIDs, the CPU usage, so that's a very busy application here, the memory, and the age in second. And here, the Django application, which is quite sleepy. And you also have information about Circus processes as well, because it's important to watch if they don't eat too much CPU, especially the stats. Circus HTTPD. Yeah, I have a demo time. All right, so, Okay, I'm going to stop it and restart it. Bum, bum. Okay, so here I have a Circus file with stuff. I'm running 3 processes. I'm running this program here. So let's go. I should have screencast it. I'm running a lot of stuff on my computer, so okay. So I did exactly what I said I wouldn't do. Okay, let's try again. What the fuck? All right, let's talk about this later. So you'll have a Circus HTTP demo before the end of the conference, or before the end of the year, I swear. All right, so we're happy with this system because we can now provide to our ops a simple configuration file in our Python project and say, hey, my Circus file is here on the top, and they can tweak it, and they can just run our Python application using Circus everywhere. For now on at Mozilla, in the services team, every new project uses this pattern, so it simplifies our life with ops. Let's see if it's back. Yeah. Okay. Demo. Okay, so this is the web dashboard. So one nice thing about the web dashboard is that when you run it, it's going to use a multicast call to see if there are several circuses running in your network, and you will have a Dropbox, and you can say, hey, I want to work with this circus on this box, and then you're in the dashboard. So here I have a table with all the workers that are running, and on the bottom here you can see real-time graphs about the Circus system itself, how much CPU it uses and memory it uses for CircusD, CircusDstat, and the web console as well. And if I click here, I can see all my worker, and I'm going to make them a little bit busy. I should do it. So yeah, look, it moved. Here. Woohoo! Let's make things move here too. Yeah. Okay, anyways. So it's a very simple dashboard. You have a front page with all the stuff that's running, and you can click on a worker, and here I can just click on plus and bam, I have a new process running. Or here, if I click on this button here, I'm going to kill the process. Stuff like that. And you can see all the options here, and you can also add a watcher here instead of doing it from the command line or the file. So it's enough to do whatever you want with the system. Ops don't use it. I don't use it because we use the command line tool instead. But I know that out there, a lot of people like to have a web dashboard like this. So yeah. All right. All right. So Circus, as I said, provides a way to manage your processes, but we still had one problem. We have 2 levels of supervision. Here you have SupervisorD or Circus that is watching JUnicorn, Elasticsearch, SariD, and Sentry, but it doesn't watch Django here for a very good reason. Django processes are forked by JUnicorn, and it's JUnicorn who supervises the Django processes. In other words, when you have this kind of stack deployed, you can watch all the processes here, but you're blind for what's going on here. This is JUnicorn job. JUnicorn itself is able to add, remove some processes and to watch them, but it's a pity because it means that you have two levels of supervision, one here and one here. So we wanted to have the ability to deal and manage with the Django processes directly in Circus instead of having JUnicorn doing it. And the reason it's JUnicorn that watches those processes is that JUnicorn opens a socket on the port 8080 and forks the child's process here, and they all accept connection on this socket. That's how it works in most Linux system. And so basically that's why it's divided like this. So we decided to add a feature to Circus, which is called Circus Sockets. It's exactly like Apache or JUnicorn. It's what we call a pre-fork model. So basically, when CircusD is running, it's able to create sockets, and every time a process will be created in Circus, it will be able to interact with this socket. That's because child processes can accept connection and interact with sockets that were open with the parent process, and that's exactly how Apache does when you use it. So basically, Circus Socket are sockets that Circus run itself, and then you can reuse them in your program that are managed by Circus. And since it's a system level load balancing, it's done by the system. It's super fast. The data that goes in the socket is not even checked by Circus. This is done by the system. Circus opens a socket, and then all the processes that are created within Circus are able to interact with this socket. And if several processes are accepting connection on the same socket, the system will do the load balancing, and it will be super fast. Yes, I'll talk about it. Yes. So if I go back to the usual Python web stack, which are usually made with the WSGI protocol, we need a way for the WSGI app you're running under Circus to know that it's not going to run using a socket port and bind this socket itself, but instead we will tell the WSGI application to bind a socket that's already bound by Circus. And for this, instead of using the socket bind API, you use another API that's provided in Python, which is from FD. So basically, if I call from FD with FD number that is the socket opened by Circus, I will be able to interact with it exactly the same way. So we have a project called Chaussette here, which is basically a small WSGI server that reuses already open socket. So Chaussette can be run with a file descriptor number instead of a port number. So when I run a Chaussette process within Circus, instead of running it using a port number, I just use a file descriptor number. So I hope it's clear. I hope I didn't lose all of you guys right now, but. And here is, you can check out this website here that has more documentation. So, in effect, what happens is that we don't need to use JUnicorn anymore, because Circus from there is able to interact with all your Django child processes and all the other one at the same level. And Circus is the process that will bind your sockets for you. So it binds sockets, runs all those children, and those Django applications will be able to listen to incoming connection on this port. So here's an example. If I want to build a Django or a pyramid application using Circus, I can define a section called socket here, where I say, hey, I want to bind a socket on the port 8080 on this host. And then for my Django worker, I'm going to use the chaussette binary, and I'm going to pass it the file descriptor that corresponds to this socket. So what happens is that when Circus is running, it binds this socket, it gets a file descriptor number, and it replaces this variable here, Circus Socket web app, by the right file descriptor value. And that's how we launch the stuff. And to avoid security issues, what we do is we provide a flag here, use sockets to true. If you don't use this flag, you're not able to use the socket. So other watcher won't be able to interact with the socket. That partially solved the security issue, but I'll talk more about security later. Yeah, that's it. So in my example here, if you look at this file here, that's exactly what I did. I created a web worker here, and here I created a socket, and I say, hey, once Circus launch, I want this value to be replaced by the file descriptor value from this socket. Do you have any question on this part? Okay. All right, so just to make sure, we did a little bit of benchmarks to see how our stack was doing compared to other stacks. And this is the faster to slowest result. So basically, Circus and G-Event workers are a little bit faster than with Minehald or with Junicorn and J-Event. And Waitress is quite good, but it's a little bit slower. So you have a link here with the detail about the benchmark. So the bottom line is, if you run Circus to run your Pyramid or Django application, it's going to be at least as fast as if you would have used Junicorn or another stack. And the benefit is that you're able from there to interact with all your processes from a single entry point. So here, if I go to the web worker, here I'm adding new worker, and those new processes are able to listen to incoming connection on the socket Circus open. It means that I can change the number of processes I have that are in my web application in real time in this dashboard. And if you, there is also here a page where you can see what's going on in the socket. For example, if I have a lot of people on my website, I should get here the number of reads and writes that are happening in my socket. Because Linux provides a hook where you can get notified every time someone tries to do something on your socket. And that doesn't reduce the performances, that doesn't read or write anything in the socket, it's just a way for you to know that something is going on in the socket. All right, so we're working on a bunch of new features. Right now we are stabilizing the next version that should be out in maybe less than a month. We're making everything fully async. So every time you interact with Circus, the command you're sending to Circus are sent to the event loop, and that way, if you send something that takes time to be done, it's not going to block other things that are happening. We're working on stability, robustness. Circus is now in production for stuff like Mozilla Persona, and other projects, and of course we found a lot of bugs, so now we're trying to fix them. Clustering, this feature is not added yet, so we're working on adding it. And also we want to add in a web dashboard a page where you say, hey, I'm gonna watch right now the standard output and the standard error in this particular process. So who uses it? Yeah, so every new project at Mozilla Cloud Services, Mozilla Persona, there is a team in Barcelona that uses it for their projects as well. And in case you use it, let me know. I will add your name in this slide. How long I have? A bunch of time, no? Okay. But the party is just after. No, it's the... Okay, Lightning Talks. Okay. Okay, that's it. So you have the documentation here, the mailing list. We don't use it that much, but there is a mailing list. RC and the code here.
You said there is a way to write plugins.
Oh yeah, I didn't talk about the plugin. That's a shame. So you can. So back in this slide here. Yeah, here. So here we provide a plugin system that allows you to create plugins that interact with both sockets. So basically, if you go on the Circus documentation here, oh yeah, internet.
I just want to ask, what kind of events can you subscribe to?
Yeah, okay, hold on, I know what I'm gonna do. Ooh. Uh-oh. Okay, let me do this very quickly. Okay. Yeah, I love Sphinx. So we provide plugins. So plugins are basically programs that run alongside Circus and that interact with Circus to do certain things. For example, we have a StatD plugin. So the StatD plugin will simply send StatD events, stuff like this. We have a Redis observer that can be used to make sure that Redis is up and running. We have a HTTP observer, which is basically a plugin that pings certain websites and lets you know when they're down. There's the Resource Watcher plugin. For example, here you can say, if this process is eating more than this amount of CPU, do something. You have a watchdog plugin, so it binds to a UDP socket and will do something if something happened in the UDP socket. You have the flapping plugin that will let you make sure that your system will stop trying to run a process that's obviously dead. And we have a bunch of plugins like this. And you can write your own plugin. So writing plugin is basically writing a class where you have to implement a few functions. So here is an example. In this plugin, I implemented the init, stop, and receive methods. So basically, the init is called when the plugin is created. I create a file here. The stop is called when the system shuts down. I'm closing the file. And the receive is called every time an event is received in the system. And here I'm writing in the file. So basically, you can write plugin to interact with the system and do whatever you want, depending on what's happening in Circus during its run. Yep.
Hey. If I want to allow users to manage processes in the user space,
yes.
Would you propose to run one Circus for every user, or there is other way?
Okay, so when you run Circus, you can define the user ID and the GID. It's an option. So what I would do is have one Circus per user, unless, I mean, it also depends on what kind of application your user are running. So if they have, like, I don't know, each one of them have a Django website, it's a good idea to have one Circus per app. And then you, as an admin, you can have your Circus console and interact with all of them. You'd simply point the Circus you want to work with.
So, but I will have to reconfigure it, right? There is no way to allow users only to reconfigure their own processes, or it is?
Well, each Circus runs with a configuration file, but it also accepts environment variable and stuff like this. So you should be able to set up something that's not to be touched by the users.
Okay, thanks.
So there is a very, very comprehensive guide for all the options we have in Circus. So if you go in the documentation, there is a configuration page where you have here a very detailed list of everything you can do in the ini file. So basically, oh shit. There's an example here, and in the Circus main section, you have a lot of options. In each watcher section, you can define the working directory, the UID, GID. If you want to copy the environment variable when you launch the process, if it auto starts, you can also use the R limit feature of Python. Just limit the process to use that much of CPU, etc. You can define where the streams, the standard output and error streams are going. And we provide a few default stream functions, but you can write your own. Yeah, a bunch of options. Any other questions? Yes. Yes.
Ideas. I know that you are using in virtual env and stuff like that.
Yes. So yeah, systemd is quite similar to Circus because it also have a pre-fork feature for sockets. But as far as I know, it's also at the root level. I'm not sure how it interacts with the user environment. And the thing is, now that we have Circus in place, what we are doing is that ops are writing their own plugins, and we start to have a library of plugins. So I guess we're a Circus shop now. Anyone else?
Hi. Are you planning to take advantage of the reuse port socket option?
Oh yeah, I've seen that.
Because I hear that G-Unicorn developers are already thinking about it.
Okay, yeah, I've seen that. It would mean that we would basically redo all the socket part we have, but yeah, that would be a great feature to have. But is it already in the latest Linux kernel?
Yes, I think so.
Okay. Do you want to contribute it?
I would love to.
Okay. Anyone else?
I guess that's it.
All right, thank you very much.